Hi, I'm Darren, and welcome to Level Up EE Lab. Today's episode is back on the Simple Amateur Radio Receiver project, and I'll be going through progress on the bandpass filter construction. I usually spend an episode talking about all the great things that's happened on my projects. Well, if you've watched the trailer for Level Up EE Lab, you know one of my principles is to go through the bad as well as the good, meaning to talk about some of the pitfalls and errors that I run across so you can avoid them for your own projects. And that's the central theme for today's episode, starting with some things that went wrong on the bandpass filter builds. The first snafu was with the toner transfer. Now, I've done this process dozens of times with great results. Just look at how good the audio board turned out. All the traces are sharply defined, and the tin plating looks great. And here's another board that I recently fabbed for a different project, and it has a footprint for a 3mm square MSOP package. Holy mackerel, Batman, those 0.65mm space pads sure are crisp. So rarely do I have even minor issues with this process, but not so with these bandpass filter boards. My usual method is to start with an oversized blank and use a small piece of tape to position the paper, then trim to net size after running them through the laminator. In this case, I decided to trim them to net size first, and that was a mistake. I couldn't keep the paper aligned to the board, so I wrapped them in tape to hold the paper in place. Well, those layers of tape acted like insulation, and the toner didn't get hot enough to transfer underneath the tape. So after a couple of cleanings and retries without tape, I managed to muscle through it all and make etched boards. The next issue was with the tin plating. My homemade tin solution is fine. The problem was I apparently didn't clean the boards well enough after I removed the toner. The tin finish turned out pretty crappy. Lesson learned, give them a light pass with 4/0 steel wool before tin plating. That restores a bare copper surface that the tin solution loves. But wait, there's more. I intended to have the 4-pin headers spaced apart an integer multiple of 2.54mm so I could use a standard breadboard as a jig for alignment. But apparently when I drew them up in KiCad, I had the grid spacing set at 1.25mm, not 2.54, and you guessed it, I was off by half a row. And when did I find this error? Naturally not until after I finished 4 bare boards and started assembly. Now, I suppose I could have just adjusted the socket spacing on the receiver board design to compensate, but no, I personally can't stand stupid little mistakes like this, so I decided to make yet another batch of 4 boards. And that turned out to be the last straw. I unknowingly set the wrong print parameters and didn't get dense enough toner on the paper. The light printing wasn't visible to the naked eye on the paper, but after I etched them, you can clearly see the enormous amount of Swiss cheesing. Now, there's normally a little of this effect, but some of these traces are barely even connected. Now, I was able to make 2 of the 4 boards work well enough to make functional filters, but at this point I'd had enough. I stopped from trying any further and just ordered bare boards for the remaining 8 filters. But there is some good news from this debacle. I was able to build good 160mm and 15mm filters from these 2 hobbled boards. Let's look first at the 160mm filter. You can see now the purpose of those 2 tabs. They're for wire ties to secure those large T68 toroids. And here's the 15mm filter. It uses the smaller T50 toroids and heavier gauge wire, so the toroids don't need any extra support. So how well do these 2 filters work? Very well, actually. Here's what the measured S21 parameter looks like for the 160mm filter. This is after I trimmed a turn off the toroids and tuned the 2 varicaps to get optimal response. For comparison, I'm showing the LT Spice model performance at the same scale. And here's the 15mm version. Same drill as before, I had to trim a turn off these coils as well to get the center frequency where it needed to be. So despite a hit parade, so to speak, of mistakes that I made there, I was at least able to verify that my calculations for those two filters were spot on. And honestly, I guess I shouldn't be too surprised. I mean, after all, I'm working out of a handbook and those equations and tables are well established, and a lot of folks have built those same filters before me. Moving on to the other topic for today's episode, I want to talk a little bit about the main receiver board. Now, I think it was episode 3 I said I was about to order the board, and actually I did delay ordering it a little bit longer because I decided to finish up the software and make sure everything was working correctly to my layout, and that turned out to be a good thing because I did find a small mistake that I made laying out the Max 4820. It seems that I overlooked the fact that the Max 4820 has an exposed pad on the bottom side. I'm not used to working with TSOP and similar complexity SMT packages, and apparently exposed pads are pretty common. I only noticed the pad when I took the chip out of the package. Naturally, I'd run several traces under that chip, which would have prevented soldering the pad to the ground plane, and even more disturbing, would have forced the thin layer of solder mask to be an insulator between the pad and the traces. Definitely a mistake. I couldn't reroute all of the affected traces on the front side copper. There were just too many crisscrossing each other around the perimeter of the IC. Maybe I could have put a bunch on the backside copper and connected them to the front with vias, but that would have grossly broken up the ground plane. And for sure, I did not want to go to a 4-layer board. What I did was redesign it for a TSOP 14 adapter board. Actually, the exact adapter board that I used for the breadboarding test of the software. There was physically enough room to fit it, and the larger 2.54mm spacing made routing a lot easier. That enabled me to maintain front-side copper routing underneath the adapter. So that was my last tweak to the receiver board design before I placed the order. It may be trite to say this, but making mistakes is a natural part of the learning experience. Being curious and being bold enough to try new things is a good thing. That's how we all grow. So with that said, what's coming up next? I'm expecting the receiver board and all the bandpass filter boards any day now. I have all the hardware, components, and accessories I need to finish this build, so that's definitely going to keep me busy for a couple of episodes. As always, thanks very much for watching. I hope you enjoyed this, and until next time, bye for now.